Welcome to video 3.8, Angle Types in Algebra. The learning target for this video is I can use algebra to solve problems about angles. So you've learned a lot about how to simplify expressions and solve equations, solve for x. We've started working with how to apply algebra to word problems, and we've done a bunch of work taking word problems and translating them into algebra equations. We're going to continue with that work, but now we're going to actually include a little bit of geometry. So before we start using any algebra, I need to teach you a few things about angles and geometry. So basically what we're running through on the front of this handout are different types of angle relationships. So relationships that two angles can have to each other. So adjacent angles are very simple. You can see in this diagram angles that are next to each other. What's important and what you'll see a lot are adjacent angles where instead of having these two curves that you see here, you actually have a little square. So you'll have a little square like that at the intersection of two lines. And what that little square means is that it's what's called a right angle, which means it's equal to 90 degrees. And so if you ever have two angles with that square, then you know that those two angles are equal to 90 degrees. So let me show you just one more quick thing. So for example, if I had a line going through like this, ignore the fact that it's going through the text, I would know that the angle up here and the angle over here, so let's call this angle A, and let's say down here is angle B, that angle A and angle B would add up to 90 degrees. All right, let's keep going. So those are adjacent angles. Vertical angles are angles that are right across from each other at an intersection. So when two straight lines intersect, you get four angles. So you can see that right here. Two straight lines cross, and I have four angles. 1, 2, 3, 4. The angles that are immediately across from each other are called vertical angles. The word intersect just means that they cross. And here's the important part. Vertical angles are equal to each other. So in this diagram, angle A and angle B would have to be equal. So if angle A was 22 degrees, then you know angle B is also 22 degrees. So here we have three adjacent angles, to use the vocabulary that we've been learning, A, B, and C. What's important that you need to know is that when you have three angles that when you put them together give you a straight line like this, all of the angles will add up to 180 degrees. So all the angles on a straight line add up to 180 degrees. And last but not least, here, instead of just going on a straight line, we have angles that go all the way in a circle. So angle A, B, and C make a full circle around a single point. So all the angles around a single point, so they add up to make a circle, add up to 360 degrees. So when someone talks about, doing a 360 degree turn or 360 degree anything, you're talking about going all the way around. This is where that comes from. So when we're talking about all of the angles around a point, all the way around, we're talking about 360 degrees. And degrees are the measurement we use to measure angles. So here's a bunch of angle facts that we just learned. We're going to solve some problems now that will involve combining this knowledge with algebra. So let's take a look at this first diagram. What do you notice? You should notice a few things. One, the square means 90 degrees, and that I have a straight line. So all of these angles together have to equal 180. And so if I wanted to figure out what x is equal to, I could set up an algebraic equation, because I know that angle 3x plus 90 degrees plus 2x, so those are the three angles on this line, have to equal 180. And I know that because all of the angles on a line equal 180. So now I can actually figure out what x is equal to. You should start by recognizing that 3x and 2x are like terms, and I can combine like terms. So if I combine like terms, I get 3x plus 2x is 5x plus 90 equals 80. So now I want to subtract 90 from both sides to isolate my variable, my term with the variable. So if I subtract 90 on the left, minus 90, minus 90, I get 5x equals 90, because 90 minus 90 is 0, and 180 minus 90 is 90. So I'm almost done, but in order to isolate my variable x, I'm going to need to divide both sides by the coefficient, and the coefficient here is 5. So if I divide 5x by 5, I just get x. And if I divide 90 by 5, I get 18. And so here, my final answer is that x equals 18. Now, if I actually wanted to figure out what the different angles are, I would have to go back and substitute in. So here, we know that this angle is 2 times x. If x is equal to 18, then that means that this angle is 36 degrees. And I could do the same thing over here. So if this angle is 3x, 3 times 18, because x is equal to 18, gives me 54 degrees. And so I know that this angle is 54 degrees. All right, let's move on to example 2. So in example 2, I have two different variables to solve for. Let's start with x. So what you need to recognize here is that all of the angles on a straight line equal 180. And when I take 144 and x together, those two angles make up a straight line. And so 144 plus x must equal 180 degrees. So now it's just, again, a simple algebra problem. If I subtract 144 on the left, and I subtract 144 on the right, I'm left with 144 minus 144 is 0. So x equals 180 minus 144 is 36. And there is my value for x. So this angle is 36 degrees. Angle y, I actually don't need to do any math. And the reason for that is I know that vertical angles are always equal to each other. And because y and 144 are vertical angles, they're across, they must equal the same thing. So I know without doing any math that y is equal to 144 degrees. Let's move on to example 3. So this one's actually quite similar to the first one. I have two angles, 2x and 3x, And I know that together they have to add up to 90 degrees. And the way that I know that is because of this little square at the bottom that means 90 degrees. So I can turn that again into an algebra problem. 2x plus 3x has to equal 90 degrees. So when I add it all together, they must equal 90. So from here, it's an algebra problem. Again, the first thing you do, combine like terms. So 2x plus 3x is 5x. So 5x equals 90. If I divide both sides by 5, then I get x equals 18. From there, I could figure out what each of these angles is equal to. All right, last example. Here, this one's a lot trickier. I know this angle in here is 3x. I know this little one is 16, and this big one is 85. There's no 90-degree angle sign, so I can't assume anything is 90 degrees. I know all of the angles on a line have to equal 180, but I don't really have enough information to do anything with that since I know absolutely nothing about this angle or this angle. And so the angle property that I'm going to end up using is the fact that vertical angles are equal. So what that means in this case is that this sort of whole slice, let me try and show you. There we go. So this whole slice and this whole slice are vertical angles. They're across from each other, so they have to be equal. And so I can turn that into an algebra problem. And it'll look like this. If these two yellow angles are equal to each other, then 3x plus 16, because this large yellow angle on top is going to be the 3x plus the 16 degrees, has to equal 85. So you see how that went from something that looked fairly complicated to being an algebra equation that we know how to solve. So I recognized that the 3x and the 16 together has to be the same as the 85 because they're vertical angles. It doesn't matter that this one is further split. So now it's an algebra problem I can solve the way I'm used to. I need to start by isolating my term that has a variable. So the term with the variable is the 3x. So I need to subtract 16 from both sides. 3x plus 16 minus 16, that got weird. There we go. Plus 16 minus 16 disappears. 85 minus 16 is 69. 3x equals 69. If I divide both sides by the coefficient here is 3. If I divide both sides by 3, I'm left with x equals 23. And that's how I solve for x. So much like what we've already been doing, what's difficult here is that there's no rule for how to solve these problems every single time. Every problem is going to be a little different. And so what you need to do is always go back to these notes, look at the examples I've given you, and ask yourself, what am I given in the diagram? And which of the angle properties, or which combination of the angle properties, is relevant, and how can I use that information to set up an algebra equation? The first thing you should always do for every example is set up an algebra equation.